Hello class, today we're going to talk about section 4.4, which is parallel and perpendicular lines. By the end of today's lesson, you'll be able to find equations for both parallel and perpendicular lines using given information. Two parallel lines are lines that never intersect and they have the exact same slope. That having the same slope is going to be key for us to figure out the equations associated with the line. Over here on the right, you will see an example of two parallel lines and their corresponding equations. The line with the red dots is 1/2 x plus 3. The line with the blue dots is 1/2 x minus 2. The other lines we're looking at are perpendicular lines. These lines intersect at a right angle or a 90-degree angle, and they have opposite reciprocal slopes. So what the opposite part means is that one of them is going to be positive and one of them is going to be negative. The reciprocal part, if you remember back to last year when we talked about division of fractions, reciprocal means flipped over. So when you look at these equations down here at the bottom, our first one is y equals 1/2 x plus 3. Again, that is the line with the two red dots. Our second equation, or our perpendicular line, is y is equal to negative 2x minus 2. That's the line with the blue dots. When we're looking at those two slopes, we have 1/2 and we have negative 2, which we turn into a fraction, is negative 2 over 1. If you notice, the second slope is flipped over compared to the first slope and adds a negative. So the key thing with the perpendicular is flipping over and either adding in or taking out the negative. We're going to start looking at parallel lines. So we're going to write the equation in slope-intercept form for the line that passes through the point 4, 1 and is parallel to y is equal to 1/4 x plus 7. When we're looking for our pieces of information, we're going to need to use that point. The only relevant piece of information from the equation that they give us is 1/4. The only part that we care about is the slope. So if you want to go ahead when you're looking at a problem and cross out the rest of that equation so you don't accidentally use it, that's totally fine. The only piece we care about from the equation is the slope, which in this case is 1/4. Parallel lines means that we have the exact same slope. So our slope is 1/4, our x1 point is 4, and our y1 point is negative 1. This is going to go back to writing equations in slope-intercept form. So our y is equal to negative 1, and then slope of 1/4 times 4 plus b. Solving this, we get negative 1 is equal to 1/4 times 4, which is 1, plus b. In order to solve for b, we are going to subtract 1 from both sides, and we get negative 2 is equal to b, giving us a final equation of y is equal to 1/4 x minus 2. If I go and look at that original equation again, we have the same slopes, so 1/4 and 1/4, just with different y-intercepts. There is another way, using what we did last section, to figure out this equation. If you wanted to put it in point-slope form first. Again, we are only caring about the slope from the original equation, but you could do y minus y1 is equal to slope times x minus x1. Minus a negative turns into a positive. Then, like we talked about last lesson, you would have to go ahead and use that distributive property. So we get y plus 1 is equal to 1/4 x plus 1/4 times negative 4, which is negative 1. In order to finish solving, you would subtract 1 from both sides, giving us a final answer of y is equal to 1/4 x minus 2. If you notice, both the purple equation from the first method and the blue equation from the second method give you the exact same answer. It does not matter which way you choose to solve this. So you can either set it up immediately into slope-intercept form, solve for b, and then write your final answer, or you can set it up in point-slope form and rearrange to find that that slope-intercept form. Either option will work. Go ahead and try this one on your own. You should have gotten an equation of y is equal to 2x plus 11. What I have shown here on the board is using the point slope option. If you used the slope-intercept option solving for b, and you have a question about something that you did, please let me know when you get to class. The other thing that we're looking to find today is perpendicular lines. So we've got the writing the equation in slope-intercept form for the line that passes through the point -4, 6 and is perpendicular to 2x plus 3y is equal to 12. Right now this equation is in standard form. We could rearrange it to slope-intercept form to find that slope value, but there is a shortcut. So there is a shortcut if you're in standard form and you want to pick out the slope. That shortcut is taking the negative a, so a negative of what's in front of x, and putting it over b, which is what's in front of y. So if we're taking the shortcut method here, looking at this equation, a is 2 and b is 3. So our slope, using the shortcut, is -2 over 3. If that doesn't make sense to you, you can go in and rearrange the equation. So taking 2x away from each side, you get 3y is equal to -2x plus 12. And then dividing both of those, all three of those parts by 3, y is equal to -2/3 x plus 4. Again, giving you that slope of -2/3. Personally, I like taking the shortcut way and just using -a over b. Next, when we're looking at perpendicular lines, if you remember from that first slide, we are looking at opposite reciprocal slopes. So we've started with our slope of -2/3. I need to turn that into the opposite reciprocal. So since we started with a negative, we want to get rid of that negative because we can only have one positive slope and one negative slope. And then we want to flip it over. So our perpendicular slope is going to be 3 over 2. First slope, or our original slope, was -2 over 3. Flipping that over and taking away the negative, we get 3 over 2. This is the slope that we are going to use to find our perpendicular line. Again, I'm going to walk through both of the options for how to find the final answer. Starting with our slope-intercept form, I'm going to go ahead and plug in y, which is 6, is equal to 3/2 times -4 plus b. This gives us 6 is equal to -6 plus b. When I finish solving that up, I add 6 to both sides, getting an answer of 12 is equal to b for a final slope equation of y is equal to 3/2 x plus 12. So that's our first option using our slope-intercept form of the equation. Our other option is to start with point-slope form. So y minus 6 is equal to 3/2 times x minus -4, which turns into x plus 4. Again, your first step here is going to be to use the distributive property to get rid of the parentheses. And I end up with y minus 6 is equal to 3/2 x plus 6. So we have 3 times 4, which is 12, divided by 2 gives me 6. To finish solving this problem, I'm going to end up adding 6 to both sides. Again, giving me the final answer of y is equal to 3/2 x plus 12. Whichever option works best for you, slope-intercept or point-slope, please do that one. Go ahead and try solving this one on your own. First thing you need to do is pick out your slope, which is 1/4. The perpendicular slope, we have to flip over and add in that negative this time. So our perpendicular slope is -4/1, or you can use, to simplify it, just -4. Again, I went through and did the point slope method. That's the one I find to be easier. But either way, you should have gotten a final answer of y is equal to -4x plus 23. Last thing we have to deal with is word problems. So we're looking at, on the plans for a treehouse, a beam represented by QR has endpoints at Q and R. The connecting beam represented by ST has those two endpoints. We are looking to see if the beams are perpendicular, which means we need to find the slopes. So first, looking at QR, I'm going to label this x1, y1, x2, y2. Using our slope equation, I've got y2 minus y1 over x2 minus x1. 8 minus 2 gives me 6. -1 plus 6 gives me 5. So our slope of line QR is 6/5. Next thing I'm going to check out is the slope of ST. So we're going to start with x1, y1, x2, y2. 5 minus 6 over -8 minus -3. Turning it into a positive gives me -1 over -5 for a final answer of 1/5. Looking at our two slopes, 6 over 5 and 1 over 5 are not the same, so they are not parallel, and they are not perpendicular either. In order to be perpendicular, we would have had to get a second answer of -5 over 6. So we would say, no, the slopes are not perpendicular. Or you can abbreviate it to perp. The explain part of these types of problems is showing your work, so you do not need to really expand beyond there. Go ahead and try this one on your own to determine if they are perpendicular. In this case, AC has a slope of 6/7, BD has a slope of -7/6. Those two are opposite and reciprocal, so this is a perpendicular situation. If you have questions about this or anything else in the lesson, please let me know when you get to class.